Let's take a look at the did I get this problem for 3.10. This is related rates. And I'll model for you the way I'd like you to calmly analyze a problem on an exam. You got to read it at least twice before you start scribbling anything. Sand is dumped into a pile at a rate of 50 cubic meters per minute. The pile of sand forms a cone where the height h of the cone is twice the radius r of the cone. Find the rate of change of the height of the pile of sand when the height is 15 feet. The equation for the volume of the cone is V equals 1/3 pi r squared h. And then take a moment, reflect on what you've seen. It started out with some kind of per minute thing. It talked about piles of sand with height. Then it moved to asking about rates of change and talked about height again, and then it gave a volume formula. And we glance at the volume formula again, we see a V, an R squared, and H. Those are some variables. Okay, now we read it again. Second time, let's pay a closer attention and start kind of verbally analyzing all those little details that we saw in the first situation, the first read through. Sand is dumped into a pile at a rate of 50 cubic feet per minute. So I think it's pretty important for us to immediately go rate, right? We've got a rate here. So that's a d something dt, right? A derivative with respect to time, and it's cubic feet, and that's volume. So I think I can start scribbling. I think I feel safe if I scribble this. dv dt equals 50. It's dumping into a pile, so I'll assume into the pile is positive, right? It's not like a draining tank or anything like that. The pile of sand forms a cone. Okay. Just draw a cone, not to scale. Nobody cares. You just need the ratios. Where the height h of the cone is twice the radius r of the cone. And that reminds us, right? They're getting us warmed up for, what do you need to know? You need to know the radius and you need to know the height in order to figure out stuff about the cone. The pile of sand forms a cone where the height h of the cone is twice the radius is. Hey, that's equal. That's an equality right here. H is twice r. So now I know h equals 2r. Now this is powerful. This is like I can get rid of a variable, kind of like when you used to have systems of equations and you could solve one variable in terms of the other and then plug it into the other equation. So if I can find an other equation, I can plug in this and get rid of one of the variables. Let's keep analyzing. Find the rate of change of the height. Find. This is what we are actually looking for. Find the rate of change of the height. So, okay, dh dt, right? Rate of change is a time derivative, and h is our variable, right? And that is our variable. That's the question mark. That's what I have to solve. So I have two rates, right? One of these rates is given. One of these rates is being asked about. They're somehow related to each other. This is definitely a related rates problem. Of the pile of sand when the height is 15. So we want to figure it out when h equals 15. We want to know that dH/dt when h is actually 15. So at the instant, right, the sand keeps piling in, but at the instant we're 15 high, and therefore 7.5 wide, right? Height is 2r. At that instant, we'll want to know how fast is the height getting taller. Well, I did mention that dH/dt, right? We want to relate these rates somehow. We're not given that relationship in the rates, but we are given a relationship in the original variables, the volume formula for this cone. So the way to make related rates out of a function, right, related variables, is to take the derivative. Now, remember what I said earlier about this is powerful? You've got one variable in terms of the other. You can get rid of any variable you want. You can get rid of h and have it all in terms of r, or you can get rid of r and have it all in terms of h. We have to decide which one we want to do now, and the answer is pretty clear. We're looking for dh dt at a given height, so we really do want to get rid of r. So to get rid of r, we have to solve for r, right? So that's not too hard. R equals h over 2. All right, so this is what we're going to substitute in to get our new volume formula. Volume equals 1/3 pi. R is being substituted away, so that's h over 2 squared, and there was also the h at the end. Let me make that look like an h, not an n. Trust me on the algebra. Check it on your own. It isn't too hard to figure out that this is, I'm simplifying a little bit, pi over 12 h cubed. Volume is now in terms of height. We want related rates. We want the time derivatives to relate to each other. So we're going to take the time derivative of both sides. So the time derivative of v is, of course, dv dt, right? Pretty easy to take the derivative of a single variable with respect to another. For the other side, you need to invoke the power rule. So it would be 3 times pi over 12. And then, of course, we reduce the power by 1, but h is a function of time. So you have to do the chain rule. You have to multiply by dh dt at the end. That's the thing that most people forget. That's where people get jammed up. They forget h and v are both functions of time. So whenever you're dealing with derivatives, it's got to be chain rule if it's not just simply h, right? If we had simply pi halves h, oh, okay, pi halves dh dt, done. A single variable just becomes its own derivative. But when you have powers of the variable, square roots of the variable inside trig, whatever, then it's no longer simple. And when things aren't simple, the chain rule comes into play. Well, now we're essentially done. There's really not a whole lot to do left because we're solving for this. And we know the height, right? That's given. These are all constants, so they're given, right? I mean, let's simplify that to pi over 4, I think. That's not too hard. And oh yeah, you know, dv dt, that was the very first sentence of the problem. That's given too. So we're going to use the givens, right? 50 equals pi over 4 times 15 squared. And then that's all multiplied by dh dt. And again, you know, not to slack off on messy algebra, but go ahead and do the messy algebra, right? This is just numbers. Of course, be careful, right? If the answer key is in decimal format, go crazy with your calculator. If the answer key is in fractional format with pi, exact form, you might want to do the, you know, the reducing of stuff by hand. If you know you're not great at that, then don't do the reducing by hand. Instead, go crazy with the calculator. And then you'll have to take the time to plug in all of the answers into your calculator until one of those numbers matches the result that you have, right? DHDT, when you solve, I'll move over here, right? Without thinking about it, right? It's 50 over sorry about that, pi over 4. And then I'll just make the 15 into 225. Right. You can see a bunch of 25s in there, right? The 50 has got two 25s. The 225's got, I think, what's that, 9 25s in it. So a bunch of stuff's going to cancel. It won't be too terrible as an exact form fraction. On the other hand, that's just a couple ticky-tackies on your calculator. So do whichever you want, or decide that you're going to do whatever gets you directly to the way the answer key is written. So finish off the little bit of arithmetic. It's not even algebra, right? You already did the algebra up here, and now you're just plugging in the known values to get things done. Almost every related rates problem is going to have this feel. You're going to be given some kind of rate of change. You're going to be told something that relates the variables within the shape, right? Many shapes have two variables. You'll be told something that relates them together, and then you'll be asked a question about another rate, and they'll say when, right? Meaning at the instant, right? So that gives you the number to substitute back in, the 15 at the end. So almost all related rates problems are quickly identifiable. What you need to remember is when you take the time derivative of something with other variables, everybody gets the chain rule. So that's like the big takeaway that I'd like you to take away with you. Everybody, everybody gets the chain rule. And that's how you get the related rates. If you forget that everybody gets the chain rule, well, you're not going to have any related rates to solve. So make sure you remember that that key trick to getting these done.